All right, greetings and welcome back. So in the last video, we saw how to create a material, how to work with some of the basic properties of a material, start connecting a few nodes together. Now we're going to push things just a little bit further, and we are going to add some textures to our material. Now, if we get the material editor out of the way for just a moment, as a matter of fact, I'm just going to close it. And if we look here inside the content browser, we see a lot of different materials that come with the starter content. So I'm going to grab one of the more visually interesting ones, let's say the brick wall material. And I'll just double click this and open up its material editor. Now at the end of the day, this is a very, very simple material, but you'll see that it's using some textures to define the surface. So instead of just using color like we did in the last video, we have a texture that is defining the color of some bricks, and what is called a normal map that determines how lumpy the surface is. This gives the surface the impression that the grout actually indents into the surface. I'm going to do something real quick. I'm going to hold down the L key, L as in Lima, and drag my mouse around. And if you take a look, it actually looks like there are some shadows that are being cast inside those crevices. Now, if you're new to normal maps, you are suddenly wowed and amazed. And if you're familiar with normal maps, you're probably staring at the screen like, so what? So let's go ahead and start applying some textures to our new material that we've been creating. So I'll go ahead and close this. We'll scroll back down to the bottom of the list and grab my material and just double click that. Now with our starter content, we have several textures that we can choose from to make our own materials. So let's go into the textures folder and scroll around. Also under the props folder, so that's just materials. Let's just go under the textures folder and let's see. Let's pick on, let's make some wood. Wood is a nice, generic material that you may need at some point. So we've got a few textures to help define wood. We're just going to use two of them. We have T-Wood AD, which that's just some abbreviations for diffuse or like a base color, just a naming convention. And then we have a normal map that defines wood. So let's just drag both of these into our materials graph. So you can add textures to a material from the content browser just by dragging and dropping like so. And boom, we have two textures already available. Now let's go ahead and make our material editor nice and large once again. And we're not going to use this color anymore. Let's just go ahead and remove that. And we'll take our texture sample and we're going to plug the white pin into base color. So do that first, and then we'll talk about what we just did. So now you can see our sample actually looks like very, very glossy wood. Now, as I mentioned in the first introductory video, every pixel is broken up into a series of channels. We have red, green, blue, and alpha, and those are actually shown right here. And we can use the information from any one of those channels that we like. So for instance, in this case, we're using the result of all of them. So this is red, green, blue, all combined together, and alpha is actually not combined. That is left separate in case you want to do something with the information later. But so the white pin at the top is the combination of red and green and blue to give you a final mixed result. If we wanted to, we could just plug the result of red in here, and what we get is a grayscale texture that is literally showing us how much red information is on this texture. An easy way to visualize this is within the texture editor. So with this texture sample node created, I'm going to come over here to the details panel in the material editor and double click on this material swatch. And this opens up the texture editor here inside of Unreal. I can scroll the mouse wheel back a little bit so we can see the entire texture. And while I'm not really all that interested in going through all of the nuances of how to edit a texture, that's kind of outside the scope of this video, I do want to point out, if you go in the View menu, which is here inside the little viewport here, you'll notice that you can see each one of these color channels, and you can turn them off if you want to. So if we turn on alpha and we turn off the rest of them, here's what the alpha channel looks like. It's basically a white texture with black where all the wood grain exists. And then we can turn on the other channels one by one to see what they look like. So here's what the red channel looks like. That's all the red information you have. And if you're wondering why it's gray and not red, it is just a grayscale value where 0 equals no red information and 0 is going to be equal to black. A value of 1 or white would be full red information. Like you're using all of the red information that you can possibly stuff into a single pixel. So this texture has a pretty fair amount of red. Green, a little bit darker, so there's not as much green information as there is red. And then finally blue, and blue is the darkest of all. So there's really not a lot of blue information either. But there is a little bit of all of them to give you your final wood color. So I'll go ahead and close this and go back over to the material editor. And so let's take our final RGB result and we'll plug that into base color. And there you go. So now we have the result of a very, very shiny wood. Now, our next value we're interested in is metallic. Is wood made of metal? You should have answered no. If you didn't, well, then you have a great imagination. We'll just move on from there. So we have a metallic value of 0. Now for roughness, we can start doing some, I guess, interesting things, but we're going to save that. I'll come back to what we're going to do with roughness here in just a moment. For now, let's just get normal hooked up, and we'll take our normal map, take its RGB value, and plug that into normal. Now, a normal map gives the illusion of lumps and bumps in a surface by simulating the actual pixels changing the angle that they are facing. So it's kind of like rotating pixels around. But you can already see the result right here. It looks like we have very shiny wood, but you actually get indentations at the location of all the wood grain, which is very cool and fun to look at. Now, I'm going to just slide our editor kind of out of the way, but I still want to be able to see the apply button. I'm going to click that and take a look here in the view. That's going to take just a moment to process, and as soon as it's done, now you can see we have a very pretty wooden surface that is all nice and shiny. You can see the indentation of all the wood grain. So now let's do something just a little bit more interesting. We're going to control that roughness. Let's just assume that this is just too shiny. We don't want our wood to make it look like we've just lacquered it for days and days and weeks on end. We could just take the roughness value that's plugged in here and set this to something higher, like 0.5. And once that processes, when we take a look, you see that that has muted things significantly. But what if we want more control? What if we want, for the wood grain, all the indentations, to have one roughness value, but have everything else have a different value? Well, earlier, when I was showing you the wood in the texture editor, you might remember that we took a look at the alpha channel. And within the alpha channel, you saw that we basically have a black and white image where white represents the main surface of the wood and black represents the location of the wood grain. We can use this as a way to create different roughness values for black areas and white areas on this image. And we're going to do that with a linear interpolate node. Now, linear interpolation is a fun thing to try to teach. It's actually very easy to understand. I'm going to hook it up first, and then I'll show you how it works. We'll actually graph it out on the chalkboard. So for now, what I want you to do is take your alpha output, which is this pin here on the bottom of the wood texture, and we'll drag that into space, like so. This is another way to create nodes that we haven't explored yet. If you just drag a wire out freely and then let go, you get the same thing you get when you right-click the mouse. And what I want is a linear interpolate, so you can just start typing linear, and you should see it listed. Also, I believe you can just type lerp, and you should see it as well, because lerp is actually the programmer's term for a linear interpolate. Also, you should also just be able to type there, or hold down the L key on your keyboard and click, and that will make one as well, because a lerp is actually a very common thing to use when you're creating materials. Now, the trick here is to determine what roughness values we want in each location. So just as one quick reminder, we'll jump and then we'll look at this real quick and then we'll move away. So we have black for the wood grain and white for everything else. Remember that. So A is going to be equal to black and B is going to be equal to white. That's how a linear interpolate works. It's going to take a value between 0 and 1, where 0 is black, 1 is white, and it's going to blend you between whatever's plugged into A and B. We don't have to plug anything in though. We can just select the linear interpolate node and change the values of those numbers right here in the details panel. So let's say that the wood grain has a fairly high roughness value, something like 0.7. Actually, let's go all the way to 0.8. I don't know what it's going to look like yet, so I'm just guessing. The rest of the surface, which will be driven by the white color, is going to have a much lower value, let's say something like 0.3. Then we'll take the alpha channel from our texture and plug that into the alpha, which will in turn drive the linear interpolate. We'll take the result and plug that into roughness, and notice how that replaces that wire. Also, you can remove wires at will by alt-clicking on any one of the pins, like so. So you just hold down the Alt key, click on either connection, and that cuts the wire out. So just so you're aware of that. So now if you take a look, our reflection has a little bit more character. Down inside the wood grain, we're not getting anywhere near as much shininess. It's only on the outermost surface of the wood. Very much like if you were to polish it, and, like when you're buffing it with a rag, you can't really get into all those little nooks and crannies, so you end up with a much more realistic result. So at this point, we have nodes that we don't need. You could just select these nodes and delete them, but one nice thing about the material editor is it will help you with that. There's a cleanup button up here in the toolbar, and if you click this, that's going to remove any nodes that are not connected anywhere into your network. Let's go ahead and slide our material editor out of the way, and we'll click the apply button. And you can see the result here. All right, so one last thing I want to do is talk a little bit about texture tiling and adjusting the texture coordinates along a surface. So if you take a look at these two texture sample nodes that were created when we dragged our textures into our material graph, they each have a UVs input. Now, without getting too technical into like the world of UV modeling, or I'm sorry, 3D modeling, UVs are texture coordinates that exist along the surface of a 3D model. If you are unfamiliar with what they are, then it would probably be best, just for the sake of this video, to do a little bit of research into UVs and how they are created for a 3D surface. In the case of the material editor, they are how we can adjust coordinates of a texture to cause it to tile more often. And we do that with a special node called a texture coordinate node. We can create that by right-clicking and typing texture coordinate, which you'll see it start to appear as you type enough. You can also just drag a wire backwards off here and do the same thing, and it'll automatically be connected. Now, what a texture coordinate is going to do, if you select it, in the details panel, you'll see U tiling and V tiling. I'm going to take U tiling and V tiling and set them both to 2. So we should have twice as much of the texture. I'm also going to plug the exact same node into my normal map. That means both of these textures will tile accordingly. They'll both tile the same way so that they're both still nicely aligned. So let's actually increase this a little more. Let's do all the way up to 3 and 3. Now I'm going to slide this out of the way and watch what happens here in the main view when I hit apply. We get a much tighter wood grain that actually looks pretty realistic. And depending on the type of surface you'd coated it with to make it all nice and shiny, I suppose. So with that, we have augmented our material to actually use some texture information. We've added a normal map. We've done a linear interpolate to create a nice custom roughness value. I did say I would explain how a linear interpolate works, and I don't want to go back on my word on that. So let's jump back over here to my chalkboard for just a minute, and let's talk about this. So a linear interpolate works kind of like this. I guess it's actually kind of convenient that I already have graph paper that I'm working on. We have value A and value B, and that actually corresponds to those two inputs on the linear interpolate node. And then we have our alpha, which goes from 0 to 1. The relationship is, as the name suggests, just a linear one along this graph. So I could just make a line just like this. So that if alpha is 0, you're actually looking at whatever the result of A is. If alpha is 1, and just to kind of drive this home, 0, if you're using a texture, is the same as black, and 1 is the same as white. So at a value of 1, you're seeing the result of B. At a value, say, of 0.5, which would be gray, you would see something that was 50% of both results. So if you're using, say, if A was red and B was blue, then a value of 0.5 would give you something kind of like purple. So that is how linear interpolate works. I just want to mention that because I promised that I would. So that is going to wrap things up for this video. In the next video, we're going to go a little bit crazy with our material and just do some fun things to it, showing off a few more of the material properties. So thank you very much.